So on page 18, we're looking at hypotenuse leg proofs. So in order to prove two triangles are congruent by hypotenuse leg, we have to prove that the hypotenuse on each one are congruent and two legs are congruent. So in order for it to be true, if BC is congruent to EF and AB is congruent to DE, and they have a right angle, then we can prove the two triangles are congruent. So then a triangle ABC is congruent to triangle DEF by hypotenuse leg. So that first proof, number one, says triangle LNP and triangle MNP are right triangles. As you can see, that's already, there's already a right angle in there on one of them. You can draw the right angle on the other one. So then that is given to us, so we can mark that as given. And then it tells us we're given ML is congruent to MN, so I'm going to mark that. That is also given. Then statement 3 says MP is congruent to MP. That is our middle side. That is reflexive property.
Yes,
I had somebody ask yesterday if you could write just RP for that. That's fine. So now we know those two triangles are congruent because we have a hypotenuse and we have a leg and they're right triangles. So reason 4 is AJ.
This is fun.
No, it's not.
Do we ever do anything like activities? Not like activities, like grade activities, like interactive activities, where we all like.
Yeah, for real. We ain't never done
We just
one.
like
I like
sit there
doing
and do
those.
notes. It's like,
That don't mean we can't do that.
and the thing is like, we're all.
It's like, look, as soon as you put a problem on the board and we have like teams, but like our teams are like,
Why don't we do
Like
that?
trash
ball.
Like hard.
Like basketball, right?
yeah, basically.
Basketball.
Yeah, I usually play basketball.
What's that? Everybody has their own ball. Everybody has their own ball.
Yeah, everybody gets their own ball.
If I ask her what it is, she
Let's
knows
see if you
how
play
to play.
tracking your ball every test we have.
She can show us how to play it.
Yeah. Ask her, Kate.
What's trash?
Okay, so on example 2, we are given triangle WBX and triangle XYZ are right triangles. I put the right angles at B and at Z. Because those are the middle of those two. And they're the ones that look like right angles. So that's given to us. We're also given that WB is congruent to YZ. And we're also given X is the midpoint of WY. So if X is the midpoint of WY, then what do I know about WX and XY?
They equal each other.
They equal each other. So I'm going to put WX congruent to YX.
Well, I put something about the vertical angle.
So I'm going to talk about that in a second.
So that's not right then.
Well, we want to prove it by hypotenuse leg, so that's why I'm proving it this way. But if it doesn't tell you how to prove it, you can prove it the way you're talking. So those are congruent, and we know that because of definition of midpoint. And then we're going to bring down our proof statement. Triangle WBX is congruent to triangle YZX. We have a hypotenuse and a leg on both, so we proved it by hypotenuse leg. So, if I just gave you that proof the way it was, okay? If I just gave it to you and there was nothing else, didn't tell you a specific way to prove it or anything, you could have proved it by a different method. You do not have to write this, I'm just gonna write it. So if we mark everything that's given, that's already there. We know that that side's congruent to that one. We've got right angles. But you also have this set of vertical angles. So you could have also done angle VXW is congruent to angle VYX because they're vertical angles. And then you would have angle, side. So technically there's two different ways you could have proven that one. Okay.
I have a question.
Yes.
What was on the IXO today about the adding and like all of that weird stuff? Are we gonna do that? Okay.
I didn't know all that was on K7. So. Okay, so on the top of page 19, we're looking at CPCTC proofs. So CPCTC stands for corresponding parts of congruent triangles are congruent. So we got the C, 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 C. CPCTC. So when you're asked to prove parts, which is sides or angles, are congruent, this is what you're going to use, CPCTC. But before you can do that, you have to prove that the two triangles are congruent. So really, you're just proving two triangles are congruent every time, except this time just has one extra line that's pretty much already given to you. So we're proving sides and angles are congruent, but first we have to prove the triangles are congruent. So normally statement 4 is where we've been ending off, but this one has that one extra step where it wants to show that the angles are congruent. So first we prove the triangle congruent, then we can say the angles are congruent by CPCTC. So we're just going to treat this like a regular proof. So it says we're given AB is congruent to AD. That's given to us. Then we're given BC is congruent to DC. And then we need something else.
AC, AC.
AC is congruent to AC. And how would we know that?
Reflective property.
The reflexive property. So now, how do we know those two triangles are congruent? Which of the 5 postulates, the 5 main? Side, side, side. So we just proved it like we normally do, but now we have that extra part. If it's ever asking you to prove an angle or side, the last reason is always going to be CPCTC. CPCTC. So it's just like a regular proof, except it has that extra thing at the end. What? So anytime you have a proof where you're proving an angle or a side, what's the last reason always going to be? CPCTC. So I already know my last reason on number 2. Okay. So on number 2, we're given PS is parallel to QR. and we're given angle QPS is congruent to angle SRQ. So the angle at P and the angle at R. So we're given those two things. Now that next statement says angle PSQ, so PSQ, this angle right here, is congruent to angle SQR, this one right there. How would those two angles be congruent?
Alternate interior.
Alternate interior.
Shut your chest naked.
Okay, so we know those two angles are congruent because they are alternate interior angles. So we can put AI for reason 3. Then it tells you on reason 4 that QS is congruent to SQ. How would I know QS is congruent to SQ?
Reflexive.
The reflexive property. Okay, so now how can I prove those two triangles are congruent? I have two angles and a side.
Angle, side, angle.
Angle, angle, side.
How do you do that? I don't do
So I just look, I know I have two angles, right? So it's either gonna be the S is between them or it's not, okay? So if the S is between them, it's always gonna be this line right here. Is that side marked as congruent?
No.
No, it's marked as parallel, but not as congruent. So I have two angles and a non-included side, so it would be angle, angle, side.
So if it's not congruent, it's not in between.
Yeah, if this side's not marked congruent, it's not in between.
Okay. And if it is congruent, it's in between.
Yes, so it would be angle, side, angle.
Okay.
You see the movie? I know I'm not the only one that saw it.
So what?
Little comment.
What comment?
They talking about stuff about man.
How's
No,
it
no,
been?
no. No, no.
It was like over here. It was like
Okay.
colors in it.
So number 3, look at what we're trying to prove. We're trying to prove angle XWV is congruent to angle XYZ. What's my last reason going to be?
CPTC.
Yes,
CPCTC.
CPCTC. So I've already got one thing done.
That's all.
Okay? So now it tells me X is the midpoint of WY and VZ. So X is the midpoint twice. So how many times are we going to have definition of midpoint?
Twice.
Twice.
Oh, and then because WX is going to equal YX and VX is going to equal ZX.
Okay, so WX is congruent to YX.
Yes,
How do we know that?
because there's a midpoint right there.
Definition of
Midpoint.
midpoint.
Very cool.
And then what other two are congruent?
VX and ZX.
VX is congruent to VX. And we know that again because of definition of midpoint. So we use midpoint twice. That's what we needed to do.
Vertical angle.
And now we do have a bow tie, so we do have vertical angles at X. So we need to name those angle WXV. W goes with Y, so we'll start with Y,
X.
X,
Z.
Z.
Come on.
And those are vertical angles.
X, W, V. What is that?
And so now we need to prove the two triangles are congruent. How are those two triangles congruent? We have two sides and an angle.
Side, angle, side.
Side, angle, side.
Period. I think it's pretty good.
Stop talking like that. I'm gonna start thinking about this.
Not me. Wrong.
Finish
Finish.
it.
What?
Finish it.
I can't.
You're gonna take it.
Wait.
Okay, so on number 4, we are trying to prove side JK is congruent to side JL. So what's my last reason?
CPCTC.
CPCTC.
Wait.
So I already got 1 out of the 1, 2, 3, 4, 5, 6, 7, 8. There's 8 things there. I've already got 1 of them. Number 1.
What? Like, there's.
So there's 8 blanks.
Oh.
So then it tells me JM bisects angle KJL. That's
means-
given.
Which means they're equal. Good enough.
So that's bisected right there. We got a bisect. So if I have bisect, I'm gonna have definition of what?
Midpoint.
Nope.
Oh, what's it called?
Angle
bisector.
I knew that.
So
Yeah.
then, I know I'm gonna have that as one of my reasons.
Isn't the other one given too?
Reflect.
So,
Isn't the, here, Charlie.
Period.
what? So, that is given angle JMK is congruent to angle JML. We know that, because it's given. And then, since we have that bisector, we know we have to use definition of angle bisector. That's gonna be my reason 3, and then we need to write the statement for that. So, angle KJM. So I just follow it, KJM. Is congruent to LJM. And we know that because of definition of angle bisector. And then we need one more thing.
JM equals JM.
JM's congruent to JM.
My bad.
Their measures would technically be equal, but we're doing proof on congruent. So they're congruent. And how are they congruent?
The reflexive property.
They're reflexive. So now how are those 2 triangles congruent? We have
Angle, side,
2
angle.
angles and a side.
Angle, side, angle.
Angle, side, angle.
I'm starting to get this done. Starting to get it rolling. I'm gonna do really bad. I don't know why. Oh, I know why. I drank a Capri Sun this morning. Then I drink another one.
Can I?
Yes.
Okay, so on number 5, it says BC is congruent to EF. Not congruent. BC is parallel to EF. My bad. So that is given. Then it says D is the midpoint of BF. So it's the midpoint of that line. Let me just highlight that there line. So I know that's the midpoint of just that line. Doesn't say anything about the other one, so we can't assume. So that is given to us. So then it tells me that angle E is congruent to angle C. Angle E congruent to angle C. They're not vertical. We don't have a bisect. Okay, so I can already eliminate those 2 choices. So they're either alternate interior, alternate exterior, or corresponding.
Corresponding.
Alternate.
Alternate
they're
interior.
Yes.
You're probably not gonna see many with alternate exterior. It's probably just gonna be alternate interior and corresponding. And on my stuff. So,
So what was the alternate exterior?
Huh?
What was the alternate exterior?
probably won't.
Okay.
But it is possible on these kinds of proofs, but not.
So we can just put AI.
either AI or corresponding when they're parallel lines, most of the time. Okay, so then it says BD is congruent to FD. How would I know those two lines are congruent?
Because they share an image.
Because they share a midpoint, so that's definition of midpoint. Then number 5 says angle BDC is congruent to angle FD.
Vertical.
Those are vertical angles. So
But
now,
if
what?
you flip that one up, it wouldn't fit.
Huh?
If you flip it up, it won't fit.
You gotta flip it up and rotate it.
But that still means it's vertical. Okay.
Okay. So, how would I know those two triangles are congruent? I have two angles
Side angle side.
and a side that's not inside of the angle.
Angle side side.
Angle,
Oh, no, you
Angle.
can have that.
side. So 2 A's and an S. Angle, angle, side. And then how do we know two lines are congruent? If triangles are congruent?
Definition.
B, T, C, T.
Wait, how do you get angle, side?
So I have two angles, right? Is this side between them marked? No. So therefore, I have two angles beside each other and then an angle, a side outside. Angle, angle, side.
So you have to follow it? Like a
Triangle.
And
Yes.
What? No, what? I'll give it a quick shot.
Okay, so the difference between angle, side angle, and angle, angle, side, it's not really that you just follow it. It's just that where the side is that you're given. So I can be given these two angles, right? If the side is between where they're at, so this side right here, I have an angle and an angle and a side between them, right? So angle and an angle, the S is between them, it's ASA. Here, if the side's here but not there, I have two angles. And is the side between those two angles or is it outside of it? So that would be angle, angle, side.
Wait, so then what's that little arrow thing? Is that not a side?
No, that is a parallel.
I was thinking that's a side the whole time.
And even if that was, that's not even between the two either. It would still be angle, angle, side too.
So then,
If where the highlight is, where that little highlighter mark is right here, if that was marked, it would be angle, side, angle. Like this one was angle, side, angle. Angle, side, angle.
It's probably a bad time to say this.
What?
But I think we're gonna have a quiz.
What? You think so?
Because we're gonna finish page 24 today. So that's what we're also supposed to do tomorrow, so we're not gonna have
I didn't know how long it would take us, so we're not actually gonna do page. We're just then we're going to similar triangles up here too.
So we're gonna have a quiz tomorrow?
Yeah.
Mm-hmm. Okay.
Yes, sir.
Wait, what happened in the quiz?
No, we didn't just say that.
Listen, I'm like, I listened
There's no
to some
excuses.
of the conversations.
There's no excuses for that.
Shut up before I really fix you.
Okay, so let's look at
I
page
was
21.
Friday night. I will do it to you too.
You stop talking.
Okay, so that's hypotenuse, leg, and CTCTC proofs. So now we're going to practice all the different